All right, good morning. Physics teachers are awesome. I think this is number 87. I think, why isn't it picking up my mouse here? There we go. This, I think, is a college lecture course, and I noticed at the beginning it was just kind of doing some policies, so maybe first day. Then I fast forwarded here to 21 minutes in, and it looks like we're going to get I think she said it was going to be a review of simple harmonic motion. Here we go.
Physics 1020, this material is going to look new to you. I'm going to do a very fast review. It'll take 20 to 30 minutes. If this is too much and you want more review, I have a longer review on our Brightspace page. So it's kind of a lengthy video with lots of examples, lots of notes.
Getting a little bit of PTSD. The spring in my garage broke yesterday. Which was very loud, and I had to go to the hardware store twice to get it fixed, but I got it fixed, and that's what this spring is reminding me of. Quick shot. She did show how thick her stack was, right? That's really, really interesting. I'm always intrigued by people who number their slides, because if you number their slides, people are like, okay, well, I know what I'm in for here. And I actually find that I don't number my slides, like if I'm giving a talk at a conference or something, because I don't know, I kind of want them to focus on what I have going. But on the other hand, in class, it kind of makes sense to say, hey, we got some stuff to cover. And I also don't know how thick each page is. So, but it looked kind of, let's see if we can back up to it. I'm just going to go back 5-second intervals here. See if we can find it. 3, 4. Was it one more? Nope, I think it's in this 5-second thing here.
If you're coming from Physics 10...
Right there. So can't really tell how thick each page is, but we know there's more coming. So that's really, really interesting. All right, here we go.
20, this material is going to look new to you. I'm going to do a very fast review. It'll take 20 to 30 minutes. If this is too much and you want more review, I have a longer review on our Brightspace page.
Oh,
so
cool.
It's kind of a lengthy video with lots of examples, lots of notes, and lots of videos.
Cool.
So if this is not enough of a review, then you can check out our Brightspace page.
I wonder how the breakdown of
and this is going to be
people
the
using
jumping
class
point
versus
for
that
our chapter
works.
15. We're going to use a lot of this terminology and these concepts when we get started on chapter 15, which we should get to on Friday. So, simple harmonic motion, chapter 14. It's the oscillatory motion of an object that moves under the influence of a restoring force. And a restoring force is defined as a force that pushes something or pulls something back towards equilibrium.
Oh, I like the pushes and
So the classic
pulls.
example is a mass on a spring. So I put a mass on a spring.
Oh, demo time.
I pull it down a little bit, and it bounces up and down.
Love
That's
it.
simple harmonic motion. There's lots of examples of that sort of everywhere.
Love it. Oh, it's smashing my face. Sorry about that.
When it bounces up and down, it oscillates. So there's the oscillatory part. So it goes up.
So this is super awesome, right? When you use like real-time things in front of them, it's just so cool because, there was nothing wrong with this, and she reinforced what it said, pushes and pulls, and then bam, she just grabbed a spring and put something on there. We already know that there's gravity involved here, so how much do you want to worry about that? But all she's trying to get across so far is that it's oscillating, which according to some of my Twitter buds is pronounced lots of interesting ways by lots of interesting people. That word, oscillating. So I just really wanted to say that this use of the demo, the physical thing is interesting. Now it's almost out of the frame, but it's perfect actually. We can see it. That's all we needed to see was that it was going up and down.
Up and down. So one complete cycle is from one position back to that same position. So say from the top down, back to the top. That's
Cool.
one oscillation.
Cool.
Things we care about is how do we describe this
Oh, did you hear that? Canadian.
position as a function of time. That turns out to go as a sinusoid, like a sine or a cosine. We care about how long does it take for one oscillation. That's the period. And we care about how many times does it oscillate every second. That's the frequency. So those are the things we're going to talk about here in this chapter 14. One sort of neat little tidbit I learned is that dogs, any dog owners, lovers? When dogs get hot and they pant, they actually pant at exactly the right frequency for their body, the resonant frequency that helps them cool off the most efficiently. So there's a little
No way. No way. So let's think about that efficiency. So the panting, if I remember correctly, is to increase air turnover in their lungs. No, I'm not sure about that. So she said that she learned that the frequency that dogs pant at is really optimized for their body. That's, oh my gosh, that's so cool, because what I am thinking about is the difference between how lucky that is, or evolution seems to have found the magic on the one hand, versus it's a feedback mechanism that even if they were to start panting at a different frequency, that it would kind of bring it back again. Now, that's probably too much for this review that's going on here, but that's when I think about oscillatory systems, I think about, is there a reason that things are happening? Does it evolve in a certain way? Does it, is there a frequency that's not only resonant but also sort of attractive for the system? So, man, that's cool. And did you also hear what she said? She said, well, any dog owners in here? So, she's really connecting to the students who, it's something that's in their lives. I thought that was really, really great.
Crossover that I think is cool. Okay, so let's start to get some notes together on all this.
Cool. There's the stack again.
So let's start. Our very first picture on that slide is a spring at equilibrium. So that's just a spring hanging on a stand.
Love it.
When it's at its relaxed length like this, nothing is pulling on it. That's called the equilibrium length. It's at equilibrium, it's not moving. So that's what equilibrium means. There's not much interesting happening right there. So the next thing we do is we take a mass and we hang it off the spring. When I put the mass on the spring, the mass has weight, so it pulls it downwards. So that's sort of the...
Okay, so she's really sort of getting at the gravity angle I was talking about before. I think some students struggle with this because effectively the equilibrium position has moved. That's one way to think about it. It's like, oh, there's a new equilibrium, so now let's measure things from there. And so, of course, you can do it either way. You could measure all of your... you could decide that the position variable 0 is here, or you could decide that it's, you can't quite see it, but at the 0 of where it's hanging. And I think that's really, really interesting to just jump right to it, because it's also, given that this is a review, it's also reminding people about the, balancing of forces and that kind of stuff. So I actually think this is a really, really interesting way to do it. You can do it horizontally if you get some sort of, nice cart or something. But vertically is just so straightforward, as long as you deal with this fact that you put a weight on it and its equilibrium is no longer here, it's kind of moved. Well, taking a look at the time, I think I'm gonna cut this short. I want to say a few things that I think are really awesome. I didn't show it much, but she did some really cool stuff at the beginning, talking about the policies of the class and ways to get help. I thought that was really, really cool. I liked the demo, of course. I really... I think these slides are working really, really well. I think the setup is working great. It's big. I can read it. I think that the demo was great. I think that the dog stuff was super, super interesting. So, I don't know. I thought this was really, really great. All right, everybody. I hope you have a great day. And remember, physics teachers are awesome.